Welcome. It's great to have you all here with us. It's easier to be a great scientist, it's good for you to know, if you're healthy. And to be healthy, you got to be eating well, getting your rest, and yes, even exercising. And that's a little easier if you're here, and I've gotten more into it. If you work at Acellus, then you have access to a really state-of-the-art workout, fitness center, which is really great, and I've gotten into that, which is good because before I got involved in it and started working out, my favorite workout used to be a combination between a lunge and a crunch. I would call it lunge, but that's really not the same thing at all. So, all right, well, a little bit of science news. First of all, we talked last week about SpaceX's launch, Starship's 11th test flight. It was a complete success. They were able to go all the way up and do a successful splashdown, which is really exciting that work is progressing, that research is moving forward. Now, this month of October is shaping up to be a really great month for those of you who like to look for comets. There are two different new comets that are coming in. One is C25A6, or Lemon, and the other one is C25R2, the Swan. And those are both going to be coming in, and you can see them with the naked eye if you have the right environment, or maybe with some binoculars you can see them even better. So check those out if you're into studying comets. Well, it's time to get it over to Dr. Joshua for How to Study with Acellus Gold.
Learning can be a lot of hard work, but it's so worth it. But for some students, it's extra difficult. There are certain kinds of learning disabilities that can make it a lot harder to learn. For example, dyslexia is a condition where students sometimes flip around numbers or words or have a really hard time concentrating. A lot of people think Albert Einstein had dyslexia. He was this famous mathematician, but he really struggled with learning math. In fact, he wrote that you shouldn't worry about your difficulties in math. I tell my son that all the time. You shouldn't worry, but because his difficulties were still greater. Well, I want you to meet a really incredible Acellus student. Her name is Maya, who had this same learning disability. And she initially thought that she wasn't good at math and that she wasn't good at science, but then she discovered that she actually, even though it took a lot of effort, was very good in those subject areas. And after coming to Acellus, she learned that she was capable of learning the material. She just needed to be able to do it in her own way, taking shorter, focused study breaks, breaking up her time really made a difference. The ability to do multi-sensory learning, where if you have to do all of your learning with reading text, that can be very difficult, but a video-based format can really help students that have dyslexia. And so Maya worked and ended up surprising her family and everyone when she graduated with honors and is now in college. So I'd like you to meet Maya Cavazos.
Hi, my name is Maya Cavazos. I'm an Acellus Academy alumni, and I graduated with honors. Acellus' program has really helped prepare me for where I am today. Despite having a learning disability where I struggle with focusing, comprehension, and reading, I have slowly been able to overcome these struggles. Today I am proud to share with you that I am an ASU college student and have declared my major in organizational leadership. Something I would tell my high school self is to keep trying, keep persevering, because what you have in you is greatness. You can overcome any challenge with hard work and perseverance.
Let's hear it for Maya.
Well, it's time to get it over to Dr. John for the Technology Spotlight.
We're going to talk about science superpowers. Oh, what's your favorite superpower? My favorite superpower is superconducting. Yeah, superconductors. That sounds like really good orchestra music, doesn't it? The conductor, right? Well, superconductors are materials that have zero resistance. Remember, when we talk about a conductor, we're talking about like a wire, like a piece of metal, and it conducts electricity. But all of the normal wires that we use have a little bit of resistance. But a superconductor has no resistance. And so you're probably thinking, well, why is that neat? Well, lots of really strange and wonderful things start happening with superconductors. For example, they did an experiment where they took a superconductor wire that they made in a loop, and they ran electricity through it. I don't know how they got the electricity in, but they left it like that, and it kept going around and around and around and around and around and around and around, and it didn't lose any energy from heat, and so it just kept conducting. And that is really strange and unusual. And of course, with zero resistance, you can have wires that are really long and they don't lose energy with heat as they're transferring the electricity from one city to another, for example. But one of the really interesting things is their reaction with a magnetic field. And I want to show you a little video of this because it's worth it. So we've got a superconductor we're putting over some magnets, and it floats. It has no friction on the surface there because it's not touching it, and so it floats around. And so they can actually make trains with superconductors that don't run on, actually touching the tracks. They float right above the tracks. And we use superconductors in MRIs when you go to the hospital and get a scan, because they need those really powerful magnets and a lot of really interesting things like that. You may have noticed in that video, though, it was like there was a mist coming off of the superconductor. That mist was not dry ice, because dry ice isn't cold enough. Dry ice is very, very cold, but superconductors usually have to be super cold, like getting close to 0 Kelvin, which is very, very, very cold. And that's why it has the mist coming off, because that's probably almost all water vapor that you can see from the air that got too close and got cold. And so for some reason, certain materials will become a superconductor when they make them cold enough. And I want to show a little bit of how this works so we can kind of understand it. This is a little bit oversimplified, but if you look at this diagram, the blue circles are like the protons in the nucleus of the conducting material, and then those red circles are the electrons. And as they move through, this is kind of what a superconducting material would look like. They just move through real easily, and so the electrons are moving, and so it's that zero resistance moving electricity through. But this isn't really how it is, because in reality, there's something called heat. And heat makes the little atoms and molecules move. They vibrate. In fact, that's basically what heat is. So here's another example of the same thing, only watch and see if you can see what the heat does. As we put more current through our conductor, that gets hotter and hotter and hotter. And the hotter it gets, the more resistance it has. And so the hotter it gets. Remember how if you heat a little wire up, or if you send too much electricity through a wire, it'll eventually burn up? Well, that's what's happening. It has a little bit of resistance, and it overheats and it melts the wire. So it's a lot like if you get it colder, then you're the opposite. You have less and less resistance. But there's a little more to it than that. In fact, they've even discovered some high temperature superconductors. But high temperature is still very, very, very cold. It's just not as cold. And the big thing that everyone's looking for that's studying this is a superconductor that works at room temperature, because there are so many wonderful things we could do. One of the neat things that people have been trying to do with superconductors is make a superconducting motor, electric motor. And Toshiba has actually made one, and I want to show you a little bit about it. Here is a diagram. On the left is a normal motor that produces the same amount of energy output, and then on the right is their new superconducting motor. And there's a little bit of a size difference. In fact, it's 1/10 the size, and 1/10 as heavy, and yet it can put out this huge amount of energy. Well, when everybody saw this, Airbus got very interested. Do you remember what Airbus does? They make the big jets. And they're trying to figure out how to make jets that are really, really efficient and carbon neutral. So let's take a look at how this might work. You can see the big jet here. There's a normal jet engine inside there, and this would be the electric motor. Now imagine if they put that huge one in that's 10 times as big. It just would not work. And people have been trying to figure out how they could make electric aircraft, and they tried ideas like lots and lots of little motors and things like that, and it doesn't work that well. But now, with this motor, it's almost 100% efficiency because of those superconducting magnets in there, the superconducting wires. And so they're working on how to put this in. But there's one big catch. Remember how superconductors have to be very, very cold? That means that they're going to have it very, very cold in the airplane. And so that's a big problem. They need another superhero, don't they? They need a super fuel. Another thing that Airbus has been working on is how to use hydrogen in aircraft. And the best way to have hydrogen in an aircraft is liquid hydrogen. Liquid hydrogen has to be kept very, very cold. And we're talking like minus 253 degrees Celsius, something like that. Very, very cold. And so they realized that this was a perfect match. If you have the cold liquid hydrogen run through the motor on its way to the fuel cell to power the motor, then you would be able to keep the motor super, super cold so the superconductors can keep working, and you'd be using the hydrogen efficiently. So they've been working on this. I want to show you a video of the prototype. This is Toshiba's prototype. Looks like a superhero, doesn't it? Wow. And so this motor they've been testing puts out 2 megawatts of power, which is really, really impressive. And if you look carefully in this picture, you can see the outer shell, how it's this insulator, because they have to keep the motor really, really well insulated in order for this to work. And they're hoping, the researchers at Toshiba are hoping that this is, of course, going to catch on an aircraft, but it's also going to be useful on boats, and maybe even someday on spaceships and things like that. A lot of really interesting applications with superconductors. A really, really neat thing. And if you think about the possibilities of a room temperature superconductor, then the future is very super. I can hardly wait. But that's all the tech we have the time for. Thank you.
Now it's time for Breakthrough Moments in Science with Tobias.
You ever heard that nursery rhyme? Goes something like, twinkle, twinkle, little star. That's not good enough. I'll change the voice. How I wonder what you are. Still not working? Up above the world so high. It's like, no, twinkle, twinkle, little star. You heard that rhyme? So twinkle, twinkle, little star. And you've probably seen cartoons where the stars are in the sky and they're twinkling. Well, it turns out that's actually real, the twinkling. And it also turns out that it's really annoying to a certain group of people, namely scientists, okay? Because actually, if you look up at the sky and you look at the stars, you might actually make out a little bit of a flicker or a twinkle with the stars. And if you look with binoculars, I've tried it before, you can still see some twinkling. And it turns out that what you're actually seeing is the light from the star going through all the turbulence of all the molecules, the atoms in our atmosphere. So it's kind of like this noise that's interfering with seeing the star. Now, if you're just looking up at the night sky, it's just beautiful. But if you zoomed and zoomed on the stars up close, all of a sudden you'd have more of that issue to deal with. So as we started to get better telescopes and we aimed them up and we could zoom in more and more, we started to get fuzzy pictures. And pictures like here's a picture of looking at Saturn with a fairly nice telescope, and it's pretty fuzzy. And some were better than others, but there was still always this turbulence of atmosphere distorting the image. So an idea that scientists had was, what if we could, this is start getting into like the 1960s and the 70s. They started looking at how could we make a system that could actually adjust the telescope to be able to cancel out that noise, that deformation that the turbulence is doing. Well, to do that, you'd have to match the turbulence, all the distortion that is happening right here as I'm looking at that star, you'd have to match that. So they made a system with a computer, and the computer would be connected to a mirror in the telescope that the light would bounce on before it comes to your eye. And the mirror would be deformable. They could deform it in very detailed amounts. And now all they needed to do is figure out how much. They needed to give the computer data of how much to change the mirror. So the idea was, okay, so if we want to look at this galaxy that's out here, we'll find a really bright star near that galaxy, and we'll aim at it, and we'll get information from that bright star. And they called it a guide star. And they tested this out. But unfortunately, while that star only seemed this far away from the galaxy they were looking at, when you zoom in as far as they are, it's much further away, and the turbulence did not match. So they weren't able to get a very good result. So that's kind of the groundwork, because we're going to talk about this lady, Claire Max. And she had a job in the 70s at the Lawrence Livermore National Laboratory in California. And she said that in the 80s, she got involved with the Ronald Reagan Star Wars initiative. And if you went through the 80s, you probably know about some of this. I know Star Wars. No, not that Star Wars. But she got pulled into a project that the organization did with the Department of Defense. So it was top secret. And what they were supposed to do was take pictures of satellites, and these satellites were moving really fast through the sky, and when they tried to focus on them, same thing happened. The photos would be blurry. So scientists had the idea, what if instead of using a guide star, we shoot a laser into the sky and we make an artificial star, and that way we can put it wherever we want, whenever we want, and we'll use that data to adjust. So they were working on this. Now, the problem is the satellite's moving really fast through the sky, so they had to kind of like move it and shoot it and try to get the information and then be ready to take the picture right as the satellite went through, and it was kind of a bit of an adventure. Well, Claire said that through all of this, as they started to get systems working, she thought, you know what doesn't move very fast through the sky? A star. And she thought, man, if we had this system for telescopes to photograph the stars, this could be a game changer. And she starts working on it once this kind of died down, these projects that they were working on. She starts working on this plan of putting together a laser guide star to look at stars without the turbulence. And so as they're working on it, they first start out with green lasers, okay? You know, green lasers, they can go pretty far. This laser could go 9 miles up into the atmosphere. Now, of course, lasers are way more focused than just a normal light. 9 miles. Turns out 9 miles is not very much when you're thinking of our atmosphere, though. And that's a problem, because you're not getting all the data that you need to cancel out. So as they were working on this, she said that they were trying to figure out how to get it all the way up, what layer they should aim for. Well, one of the scientists brought up, we have discovered that 60 miles up, there's a layer of sodium atoms 60 miles up in our atmosphere. So if we could get a laser beam that went all the way up and got those sodium atoms excited, then it could do something. Well, they worked on using a dye laser. They adjusted the wavelength of their laser light to match what would get sodium atoms excited. And it turned out to be yellow, so they had a yellow laser. And they were able to get this beam all the way up 60 miles. And it would hit the sodium layer, and the sodium atoms would get excited, and they would glow where it was hitting, and it would look like a star. And they were actually able to get this working. The problem was this was still top secret. So they couldn't share this with anybody because it was part of the top secret. And for 8 years, they worked to get this out and declassified. And finally, in 1991, it was declassified. And people could actually learn about it and start building these, and no one did. So Claire and her crew started working on building one of these that would actually be used. And so they had a lot of inventing to do. They needed to make the laser. It was like the size of a building, and they had to get it much smaller. So they're doing tests in California, and one night while they're doing tests, they're shooting their laser in the sky, they get a phone call from the police. And he's like, so we just got a call from a lady in a town about 10 miles away from the laboratory. And she says there's a UFO flying over the national laboratory right now, and it's sucking data and the secrets from the laboratory with a laser. And she said we need to come shoot it down. And Claire said actually every night that they tested and the lady saw it, she would call the police. It's back! And eventually they had a very good relationship with the police because of all the calls they got. I mean, if you see this laser that's just going up, but she thought it was coming this way, down from a UFO. Well, they finally got it to the point where it was usable and working. And they started to have results like this, where you have these stars and then they clear out and you could see things that you could not see before. And they also did it on larger telescopes where they did multiple lasers. This kind of looks like a Death Star shot. You may fire when ready type shot. But they're doing multiple lasers because the telescope's so large. And being able to beam this up and send it data of the distortion that the turbulence gave. Now, you know, this is a game changer for telescopes. And today, there are telescopes around the world. In fact, almost all large telescopes now on Earth use this system. In fact, in 2020, when they were working on looking at the center of the Milky Way, they used this technology on telescopes to analyze and study 20 to 30 stars. And because of the clarity that this guide star system gave them, they were able to decipher and determine that there was a black hole there. And that's how they led to eventually the famous discovery of the black hole. So this discovery has been just incredibly a game changer discovery, or invention really, to be able to see through the turbulence of our atmosphere and cancel it out so that we can finally see more clearly and then be able to make new discoveries. So science, engineering, a little bit of twinkling magic, and you can do amazing things. Thank you.
All right. Well, it's time for me to introduce the father of hydrogen technology, Dr. Roger Billings. You know, over the years, Dr. Billings has received a lot of different awards for his work in hydrogen energy, but one of them was in 1980. He was selected as one of the 10 outstanding young men, and this was a selection by the USJCs. This is an award that they bestow on leaders for their vigor and enterprise in attacking societal problems and offering solutions. And they said that upon receiving the award, Billings said, "One of my life goals is to create an environment where scientifically creative people can come out of college and not be so structured, but can develop freely and achieve some great things for tomorrow." Sounds a lot like a certain program that we're involved in now, doesn't it? And then a quote from the JCs, despite the success he has enjoyed in his career, Billings believes that he is still in a state of trying to accomplish. And that's something that still stays true today. Please help me welcome Dr. Roger Billings.
Here we are.
Here we are, here we are.
Trying to accomplish.
Always.
Yeah.
Ready for questions right away?
Not right away. I have an announcement first, okay?
Okay.
Some of the students have been asking questions, and one of the questions I get quite often is they want to know whether or not Paget Monet is AI.
That has happened before, hasn't it?
And so, to answer the question scientifically, I tried pushing my fingers through her.
He didn't really.
And,
No, he
and
didn't.
there's something there.
Poke?
So my theory is she's advanced AI with feelings.
I sure am.
Yeah, okay,
I really
anyway.
am.
I want to report some good news.
Okay.
Remember, we've been talking about white hydrogen, natural hydrogen occurring below the ground. And since we last talked, we have found a piece of property that we think is perfect for a natural hydrogen well. And so I'm in the process of negotiating to buy that piece of ground. It's out in Kansas. And I'm planning to drill a hole to see if we can produce natural hydrogen. Now this is kind of interesting to me. Back in the earlier period where I did this back in the last century, we drilled 10 holes, all of them hit hydrogen, but we weren't able to get the hydrogen out of the ground because it was very low pressure. I have an idea how to do that. The rig that drills holes in the ground to find oil and gas that we had was a pretty big unit. It'd come in on semis, but it could only drill a hole 2,000 feet down. Now, 2,000 feet seems like a pretty deep hole, but that's where you hit the hard rock. I want to go through the hard rock. Instead of 2,000 feet, I'm going to go down 5,000 to 7,000 feet.
It's more, isn't it?
Depending on where the big rock layer is there, because I want to punch through that big rock layer and see if hydrogen's coming up from deep in the earth, if I can get quite a bit, if we can produce it. So I'm calling this project Deep Hole. I made that up myself. Well, all right, it was R51's idea. But anyway, we call it Project Deep Hole.
Okay.
Now, the first thing we got to do is we've got to go see the ground, which I haven't done yet. I found out about it, we located it, so I'm going to go inspect it. If everything looks right, we're going to purchase the ground. And I've already talked to a company that drills holes, and this particular one has big oil rigs, really, really big. They can drill a hole 8,000 feet deep,
Okay.
which is a lot deeper than 2,000 if you do the math. And so this could be exciting. And what I'd like to do is I'd like to take you on this real world adventure with me. So today I'm going to tell you about Deep Hole. And if we can get the land acquired, then I'm actually going to give the coordinates so you can look at it on Google Earth and see where it is. Okay? And then as we drill it, I'm going to take photographs and movies and pictures and report on it each step of the way.
That's amazing.
And if we don't hit hydrogen, I will suddenly go silent.
You will, won't you?
Yeah, and that brings up a story I wanted to share with you. This is something that you need to know if you're going to be a scientist.
Okay, we're ready. What is that?
So here it is. Now this is a little bit off the record, but you need to know this. You see, there were two scientists that were studying at the university, and they were good friends, and they were learning all about physics and chemistry and engineering. And then a terrible war broke out, and they were both drafted into the army, and they were taken overseas to fight as soldiers. And when they got over there, they were divided, but one of them was captured. And as he was taken back to the prisoner of war camp, he was very surprised because he opened the door in the little shack where he was going to have to rest out the war, and there was his friend who had also been captured. So these two science buddies from college were together in the same prison at the same time. What a coincidence. Yes, this is just a story, okay? But it makes an important point.
Okay.
So bear with me.
Okay.
So here they are, and they're talking about it, and one of the guys, the guy that just came in last, he says, we've got to get out of here. We've got to escape. I think we can figure out how to escape. And he studied the fence around the camp, and he studied the guards. He studied the time. He made notes like a good scientist would. He studied everything. And finally, he went to his friend that was there longer than him, and he says, guess what? I figured out how to escape. We're going to escape. We have to go out this way. We have to do it at a certain time. And the guy said, no, I don't think we should. What? He said, I've got a flawless plan. It's going to work. I can get us out of here. We can be free. Well, I don't know. So finally, the guy that arrived there second decided he was going to have to do it alone. So he waited till just the right time when the guard went by, and he snuck out and he climbed the fence and he got away.
Just like that.
But there's more story.
Oh, but there's more.
Because the next morning when the sun came up, he looked around, and this camp was located out in the middle of a desert area. There was no plants, there was no water, there was no food. And he looked and he looked, and he finally got so hungry and so thirsty, he came back and turned himself in because he couldn't get away. And it's embarrassing to succeed and then find out that you didn't realize. And the part he hated is he had to go back inside that prison and face his friend that told him, no, I don't think we should. But he manned up, he went in, and he said, I'm back. Okay. He said, well, don't you want to know what happened? Yeah, tell me what happened. Well, I got out there, and my escape plan worked perfectly. I got away, and they didn't even know I'd gone. And I got out there, and we're in the middle of nowhere. There's no food, there's no water. My plan was perfect, but I had to come back because there was nothing to drink, nothing to eat. And the first scientist said, I know. What do you mean you know? Yeah, I learned that when I escaped. He said, you already escaped? Yeah, and I had to come back because there's no food, there's no water. Why didn't you tell me? I risked my life. And he said, a scientist never publishes negative results.
That is negative.
Okay. So if we all of a sudden go silent on Project Deep Hole, no, I'll tell you.
Yeah, you would.
I'll go ahead and tell you because, you know, even from failures, you learn something. Now, this is going to be an expensive experiment.
Yeah.
Yeah. I was wondering if she was going to volunteer to help pay for it, but she
Sure.
didn't. But if it works, it's going to change a lot of things. It's going to give us hydrogen that is very, very low cost. And you know, if you make hydrogen from natural gas, if you make it from electricity, whatever way you make it, it creates CO2, or you can only make it when the sun's shining. This will be hydrogen that will not put any CO2 in the environment. So it could stop global warming. It'd be a great thing. And if we can figure out how to do it, if my theories are right, which they may or may not be, but I'll never know unless I try. But if they're right, people will be able to do this in a lot of places, and it will change a lot of things, which is really exciting.
What do you mean by that? People will be able to do it in a lot of places? Because there's hydrogen in other places?
I believe that there's naturally occurring hydrogen all over.
Oh.
And we've started doing more search for it, and we're finding more and more. In the story which I told you a little bit about before, of when we found the first hydrogen well, the company that was drilling the well had drilled it, and they put the concrete around the pipe to seal up the hole so that it wouldn't leak and it wouldn't cave in. But the concrete didn't get hard. And so when they pushed the concrete out with new concrete, it immediately got hard. And the concrete company said, well, then there must be hydrogen there, because hydrogen keeps some kinds of cement from setting up.
Why is that?
But because it's a reducing environment, and some types of concrete need oxygen.
It's called Science Why. We want to know.
She's supposed to be the co-host. Anyway,
questioner.
So when they heard that there might be hydrogen, they took a sample of the gas to the laboratory and had it analyzed, but there was no hydrogen. There wasn't any. And so they were very confused. That's when they called me. And I went out there and they said, it's acting like hydrogen, but when we analyze it, there isn't any. And so that's when I did the little hearing test, because hydrogen makes everything sound screwy because it changes the frequency of the vibration of the, anyway. And I said, that is hydrogen. And they said, but when we analyzed it, we didn't find it. And that's when aha. You see, the analyzers they use to study what gases are in wells are a thing called a gas chromatograph with a flame ionization detector, an FID, and the flame is a hydrogen flame, which means it cannot detect hydrogen because there's hydrogen in the flame. And I said, wait a minute, you need to try a different detector. And so they used helium as a carrier gas, and they were able to say, oh goodness, there's a lot of hydrogen. You're going to just be like this all day, are you?
I just love how excited you get about it.
Tune her out. It's not going to
Yeah,
stop me.
it's going to be really hard
There's
to tune
always
me
people
out.
trying to stop science, and
It's going to be
we're not
really
going to let it
impossible.
happen. So
Okay.
anyway, I was pretty excited, and with this hydrogen, we can fuel our cars, we can run our homes, we can generate our electricity, we can do everything we want to. We can make industrial chemicals. In fact, one of the first things I'd like to do with hydrogen in Kansas is I'd like to make fertilizer, ammonia fertilizer, for plants to grow, especially plants like corn and einkorn wheat. You need to have nitrogen in the soil. And the nitrogen's in air, but that's not a form of nitrogen the plants can absorb. It has to be nitrogen in a chemical form like ammonia or like ammonium nitrate, some kind of ammonia form. And ammonia is really nitrogen plus hydrogen. One little cute nitrogen atom with three very, very cute little hydrogen atoms is ammonia.
So what you're saying is that when this happens,
Here it
because I
comes.
believe it
Here
will,
it comes.
we're going to be happier. The world's going to be happier.
I'm already happy.
I know you are. But a lot less stress, a lot happier, and a lot...
You know, in all of my projects, I always start out believing it's going to happen.
Of course.
And so it makes me happy. I'm already happy because a deep hole. I'm going to have so much fun doing this.
We should have some
I'm
shirts
going to go
saying
sit on the
Deep
rig
Hole.
and
We're part of
and
Deep
you,
Hole.
I'm going to take you with me. It'll be
That's
fun.
really fun.
Okay?
Okay, you ready for questions now?
No. And one more thing.
Oh, what?
One more thing.
One more thing.
Today, I bought a helicopter.
I didn't know that.
Yeah. And you know, I'm a fixed wing airplane pilot.
You fixed wing.
Yeah, the fixed wing, and a helicopter is called a rotating wing. Okay,
Rotorcraft,
it's a
yes,
different
it
rating.
is. Mhm.
So I'm fixed wing pilot, but I have taken about 22 hours of instruction on helicopters, and you need about 40 minimum to get your license. So I'm going to get my license so I can fly out there and check on the oil
That is
well
awesome.
and fly back.
That is
So I'll give you
wonderful.
some nice aerial shots too. Okay, it's your turn. Go ahead.
We want to know, the
Okay.
students and me, in the nitty-gritty detail, how does a hydrogen engine really work?
Oh, it works really good.
Oh, come on.
It works really good.
Okay, we want to know the mechanism
The
of it.
mechanism. Is that why this is here? So we can use this as a prompt?
I don't know why
Yeah,
that's
this is our little engine.
Okay.
So here's a chamber. Yeah, right in here is a chamber, and we have a piston that goes up and down. And as the piston goes up, we compress hydrogen with air. So we start out by opening a valve, and the air and let's get it the right way, start green here. On this side, the valve opens, and as this little valve opens, we pull in hydrogen and air mixed together. We get inside the chamber. Then as the piston rises, it compresses it. Then the spark plug fires a spark to ignite it, and it explodes and pushes the piston down fast, making that weird noise. And that drives the shaft so that you get power.
Okay.
So you just actually put in hydrogen, but you got to mix it with the right amount of air.
So there's hydrogen and air.
Hydrogen and air, and when you ignite hydrogen in the presence of air, which has oxygen, then it forms water and gives off an enormous amount of energy. Okay?
Okay.
So, in fact, I have a little clip of the first hydrogen engine.
Oh, how fun.
Before the hydrogen car, there was the hydrogen lawnmower.
And how old were you when you did that?
It's confidential.
No, it's not. We're part of your family.
All right. When I first got the engine, I was in high school. I was in the 10th grade.
Not very old.
So let's see, 10 plus 5. I was about 15 or 16. Okay?
Okay.
And I didn't understand how engines worked. A lot of people say, well, you understood. No, I didn't. I didn't.
You learned?
I had to go learn. And the internet was down.
There was no internet, by the way. That's
Rock
what he
was
means.
broken.
There was no,
And so
no AI.
I had to do it the old-fashioned way with books. But I was so determined to learn how to do it, so I had to go look up and see it. And I found out that on an engine, there's a thing that sits out here called a carburetor. I thought, well, that makes sense. It goes in a car, so why wouldn't it be a burrator? A carburetor. And a carburetor is a thing that takes air in, because the piston, when it goes down, it sucks the air in. And the carburetor also puts in some gasoline in just the right proportion that it can burn. So it mixes air and fuel. And so a gasoline carburetor has a little float valve and has an orifice, I found out. And so
That's
it has a
hole,
way of
right?
atomizing or turning the gasoline into a fine spray. So it
Okay.
mixes with the air. And if you get it too much fuel, too much gasoline, or too little, it'll burn very poorly. It'll smoke, and you have a lot of pollution, and you don't get much power out of it. So you got to have the mixture just right. It's the carburetor's job to make sure those are mixed perfectly. And the carburetor sits right here. This engine does not have a carburetor, so
doesn't.
imagine it.
Zzz. Okay, got it.
She got it. You nailed it. Okay. So I had to make a carburetor, and that turned out to be a real problem for me because every carburetor I made didn't work. One went through what Musk would call a rapid, unscheduled disassembly. Yeah. Yeah. And you know, when I would go get the hydrogen to do my experiment, I couldn't drive the first time. Later I learned how, but I wasn't old enough to drive, and so my wonderful, dear, dear mother took me down to get the hydrogen, and we had to go to the welding shop, and we got this cylinder, high-pressure cylinder of hydrogen, and they wouldn't let me buy it. She had to sign for it. And thank goodness she didn't quite realize, probably. Anyway, so I brought it home, and when that first carburetor, it was a big glass thing that I invented to mix the perfect amount of air and hydrogen. When the fire went back in it and it disassembled without being scheduled, it was pretty noisy. And that ended my hydrogen research for the second year, which is my junior year of high school.
Because of your mother?
Yeah, she thought, you know, maybe we should wait till you're a little older. I was really disappointed, but we waited. Well, my senior year, I finally was able to find out what's going on. And it turns out that when you run an engine on gasoline or diesel, but organic fuels like that, you get some carbon buildup inside this combustion chamber. And inside the combustion chamber. And this carbon, it's like soot, like charcoal. It has the property that when it gets warm from the previous cycle of the engine, and then you bring the hydrogen, it ignites the hydrogen and makes it explode while the valve is open, and the explosion goes out the intake. And it's actually very loud and very annoying. So no matter what I would do, it would always backfire and it would never run. Until I finally, well, I've got a video clip that shows this.
Okay,
Can I show it? All right, look at this. So this is where it all began. An engine runs on gasoline, originally on a lawnmower, but my dream, my idea is if instead of putting gasoline in here and burning it, you put hydrogen in, then instead of having pollution and CO2, you just have pure water vapor coming out of the exhaust pipe. So it was quite an adventure to figure out how to make this work. Now, this little blue carburetor here, I built myself. Before, it had a gasoline carburetor that you put liquid fuel in, and it mixed it with air, took it in the chamber and burned it, and it would explode and push the piston down inside. So this is how I made the carburetor. Here's where the hydrogen comes in, and here's where the air goes in, and it mixes the air and the hydrogen together, and they go in the combustion chamber to make it work. I took the gasoline carburetor off of here and put the hydrogen carburetor in, but it was really hard to make it run. And I tried a lot of different carburetors to mix the hydrogen and the air, and none of them worked. Every time I try to start the engine, it would blow up, it would backfire. Now the way that you start these engines is you pull on a rope. This would be how you start your lawnmower. Of course, right now I got the hydrogen turned off, but you pull on the rope, and as you pull the rope, you try to get this thing to go, but it would just backfire and backfire. It turns out that inside an engine that has been running on gasoline for a while, you start to build up deposits of dirty carbon. You can see inside this image that there is carbon buildup on that engine. And that's how my engine was. It was clear full of these carbon buildups. And every time that I would try to start the engine, the carbon inside would ignite the hydrogen before the valve closed, before the spark fired, and it would make it explode. And I could never get it to run. So I got my safety glasses on, and now I'm going to go ahead and start the engine. But what I want to do is I want to show you how it was back when it had the dirty carbon on there that kept igniting it. Now, if I pull this rope to start it, it turns the cylinder, but it does it just a little bit, and it sometimes will then flip backwards. And if I do this just right, it will ignite it while the valve's open, and you're going to find out what these backfires are like. So let's give that a try. I'll turn on a little bit of hydrogen. I'm going to let it flow a little bit so it builds up in there. And then I'm going to pull it and ignite it, and we might get a backfire. Let's see what happens. So open the hydrogen a little bit. About like that. And okay. Did you hear it? That is the backfire, like what I was talking about. So I made an invention, and if you come around and look at this side of the engine, you can see my invention. This is a big electric motor, and it has electricity going over to this switch. So when I turn this switch on, this motor starts turning, and it's got a fan belt connected to the engine, so it starts turning the engine. You notice this pulley is smaller than that one. That one means goes around a couple times for every one that goes around. That gives it enough power to turn the engine. Now watch when I turn it on. So now it's just being run by this electricity. But by doing that, it gave me the ability to run the engine without fuel. So then I could start adding fuel, and as I added it, it would pop and it would bang and pop until finally the hydrogen burning in there was burning the carbon out. And after a few minutes, all the carbon was gone, and then it ran natural on hydrogen. So let's try that. I'm going to turn on the motor, then I'm going to turn on the hydrogen valve and see if you can hear when the hydrogen engine takes over, and then I'm going to turn off the electricity. Here we go. Now listen when I turn on the hydrogen. Can you hear the difference? I'm going to turn off the motor. Now I can control it just with the hydrogen. So the hydrogen is going in here. If I turn off the hydrogen, it'll kill the engine. Okay? So this was the way that I was finally able to make my dream come true of an engine running on hydrogen. I had to have this big electric motor because trying to get it to work with the rope wouldn't function because that carbon was in there and it kept backfiring and backfiring, and it scared my chemistry teacher and me, and lo and behold. So sometimes just figuring out how to make the experiment right is the breakthrough that we needed to get the hydrogen engine going. So there you have it.
There we have it.
Okay. Now, one of the students that I was showing this to said, boy, you just know all about this. How do you know about all this stuff? And the truth is that when I started out, I didn't know anything about it. I didn't know what I didn't even know, I'd heard the word carburetor, but I didn't know what it was. I didn't know what a valve was in an engine. I had to learn each piece. But the funnest way in the world to learn is trying to do something you want to do. Mm-hmm. I wanted to make an engine run on hydrogen, and so I had to learn all about how an engine is built, how it works. I had to learn what a carburetor is. I had to learn the chemistry of how to mix the hydrogen and oxygen. And that kind of learning, when you're learning towards a goal, is a wonderful thing. And that's why I think our Acela Science Fair is an amazing thing, because if you decide you want to do something for a science fair project and you put a lot of effort into it, you're going to learn tons and tons and tons of stuff the fun way. And furthermore, if you decide to go to the university, they love seeing that you did the science fair. My university was paid for because I won the International Science Fair with my hydrogen car. And you say, well, but you know all that. No, I didn't. Until I started working on this project, I didn't know anything about how engines work. And you have to learn just one little, it's like building a wall. You just put in one brick at a time, and then another layer, and pretty soon you have a hydrogen car to drive around. What?
We have lots of questions. Do we have time for like one or two?
Oh, maybe for three.
Okay, so Juliet from Tennessee wants to know.
Juliet?
Juliet.
Oh,
Mm-hmm.
she's watching?
She's watching.
Hi, Juliet.
So if we run the world on hydrogen, will it change, and other students have this question, will it change the humidity and will it change the air?
Oh, it'll rain every day. It'll just be fog and rain. You know, someone has asked me that when I'm doing my demonstrations. But if you think about a puddle of water from the rain out in front of your house, and it evaporates a little bit after a storm, the amount of water we're putting in the air is so negligible, it won't change the weather at all. So that's good news, isn't it?
So Hallie from North Dakota.
Hallie?
Yes, and there are multiple students who want to know
From
this
North Dakota.
as well.
Wow. I was up in North Dakota 6 months ago. That is beautiful up there. Beautiful country. Yeah.
When drilling for the hydrogen, like you're going to be doing, the
Deep hole.
deep hole, is there a chance that the sparks will ignite the hydrogen in the hole?
How about super deep hole?
Super, that sounds
Super,
better.
that's
That sounds
a
better.
super
There we go.
deep hole.
I still think we need t-shirts
No,
that say that.
the sparks will not ignite the hydrogen because down in the bottom of the hole where we're going to hit hydrogen, there is no oxygen. There's hydrogen coming out and it's pushing the oxygen away, and so there's no oxygen, so no, it won't ignite it. Sometimes you have an oil well or a gas well that'll catch on fire, but in general, down in the hole, we shouldn't have any problem with that. And we never did in the other wells.
Really?
But it's a good question, good thinking. These kids are smart.
They are smart. They really like seeing the inventions that you're working on, so they want to see more.
And I'm not the only one working on them.
No?
Yeah, you know Little R?
Little R?
He's
yeah.
working on an invention.
Is he?
You want to see that?
Yeah, let's see it.
Okay, let's see what he's up to.
Oh, he is.
Well, hello. Hello, everybody. Welcome to the giant new Area 51. It's so big. It's too big. That's it.
Oh, my goodness, he's excited.
We're going to do some serious science because I'm going to invent a new hydrogen engine. This is the kind of hydrogen engine that just goes and goes and goes. I'd like to show you how it works. You see, what you have to do is you have to get the hydrogen in your mouth. And when you get all charged up with hydrogen, you can make it go and go and go. So watch this. I'm going to hook this hydrogen tank up here, the hydrogen like that. I'm going to turn on the hydrogen, and I'm going to breathe it. And watch what happens. You can tell when I breathe hydrogen because it makes me have a superpower. Here we go. Hydrogen on.
Ladies and gentlemen, boys and girls, listen to my special hydrogen. This is my hydrogen voice. And with this voice, I can make the engine run on hydrogen. Watch this. I'm going to blow in the hydrogen.
Oh, come on.
The hydrogen's coming out of me.
51, what are you doing? No, you're not. The engine is not running on hydrogen. It's running on electricity.
It's running on me. I'm just blowing the hydrogen in it.
Then turn off the electric switch.
Turn off the switch? Okay.
Whoop.
See, it stopped. It wasn't running on hydrogen. It was run on electricity.
Well, I know that. I know that because I stopped blowing. That's why I invented hydrogen. Ladies and gentlemen, welcome to the invention of hydrogen. Ta-da!
I'm not clapping for that. All right, well, I want everybody to start inventing. And you know, a good way to start is start being curious about things. Wonder how things work and look for ideas. And remember, not every idea is going to be a home run. So you got to go through a whole bunch. So you come up with an idea that you think might have potential. And then as you start thinking about it, you try to figure out, how would it really be used? Would people want it? Is it better than what they have? Could you market it? And lots of ideas should not be published, right?
Okay.
But sooner or later, you'll find one that's really great. And it will change not only your life, but it'll change the world. So study hard, and please consider getting ready for the science fair. We're going to have the biggest Acellus science fair we've ever had. In fact, this year, we're going to add a new invention feature. If you have an invention, we're going to judge inventions, and the best ones, we're even going to help you commercialize them.
Oh, wow.
And it's a little bit early to talk about it, but it looks like MIT is going to join with us in doing an invention fair this year. So we'll be telling you more about that. See you next time. Thank you.